Remember that a population is that overall group that's going to be studied. You, the researcher, must define this. Your population could be, like, for example, human beings, women over 40, adult males, American household incomes, etc., etc. It depends on what your question's about. Calculations that are generated from populations, remember, are called parameters. So if we would have access to an entire population and be able to take numbers from it or measurements, and then we would have what's called a parameter. Also, we've mentioned this before, but just to kind of give you a reminder, whenever we are able to calculate from a population, remember that we use these lowercase Greek letters. Okay, this is a lowercase sigma, and that's our population standard deviation. Also, from the mean, if we have the population mean, we use what's called mu. Mu would be the population mean. Of course, it can be really difficult to study an entire population, so we do need to resort to collecting sample data. And of course, that's the group of cases that's selected, hopefully randomly, from a population for the purpose of study. And it's not always randomly, as we're about to see. Okay, if you want calculations to come of it, you need to go to the random type samples. Okay? Our objective is to gather data from a representative. This is the one that is very important. We want to gather data from a representative sample. And of course, we want it to be a subset of the original population, which, be careful, because a subset is not necessarily representative. But a representative sample has the same proportions. Let's say you have twice as many girls as you have boys. Well, then you would want your sample to have twice as many girls as you have boys. We'll talk more about that later. Okay, in other words, we want our sample to represent the population in such a way that our results can then be generalized back to the original population. And we could confidently make inferences on the population, based on our sample calculations. So, okay, of course, we want to denote the sample statistics using your lowercase Arabic letters, I should have said, but English is fine. So notice you guys are all familiar with S as sample standard deviation, and of course you are familiar with X bar as our mean. Okay? Calculations that are generated from samples are referred to as statistics. Okay? Now, more about a representative sample. This contains the attributes of the population in the same proportion that they would occur in the population. Okay? And so, example, a 50% of the population of interest is male. Then 50% of a representative sample is also male. So, remember that. So, okay. Sample criteria. A list of required characteristics to be included in the target population. It allows the study's results to be generalized back to the target population, and we mentioned this a little minute ago. Okay? Again, we want our sample to be a miniature replica, I guess you could say, of our population. We want it to be in proportion, depending upon what topics you're looking at or what characteristics or attributes you're interested in studying. Okay, so we have two things to see here. We need to look at inclusion criteria. Inclusion criteria would be a list of characteristics, of course, a subject must have to be eligible to participate in your study. If you're studying a prostate drug and how it can help a man, maybe it can help people who have prostate cancer from their family to not get prostate cancer, we would obviously want to include those who have a prostate. That's basic, but it's true. It kind of, unless you hear that, it kind of like makes sense until, it's quite obvious. There's different things like that you'll run into. Now, exclusion, that brings us to exclusion criteria. Exclusion criteria would be criteria or characteristics that would eliminate or would disqualify a person from being able to participate in a study. Exclusion criteria are the criteria or characteristics that would exclude or disqualify someone from participating in your study. Okay. A sampling method. Now, this is a process that we as researchers would use to select subjects from the population in order to measure them or to collect your data. Never assume that a random sampling method was utilized when people are throwing out results of a study on the TV or in the newspaper. You should be able to identify what method was used. You'll see a little quote like a double-blind, this and that study was done over a period of 2 years. You can, anybody who has a medication with a fold-out card or something, you can kind of go see on that type of documentation. They'll tell you straight up what they've done, and they'll back it up with, this is how we did this is everything we did, and down to the letter. If a researcher or a group of researchers is not that excited to present to you how they did their sampling and their research, then I would question their motives for one thing and their bias. Okay? Now, there are two types of sampling methods that we're going to take a look at. We're going to look at probability sampling and non-probability sampling. Now, probability sampling, this would be random sampling methods where every member of the population has the same chance or probability of being selected. So, in other words, here is my population. Let's just say the area inside my box here is the population. Okay, and here is unit 1, 2. Here are all the people in my population. Okay, I have 10 people here in my population, and maybe I just want a sample of 4. Okay, but everybody in this little box has a 1 out of 10 chance of being selected for my sample, even though I'm only going to pick 4 of them. So that's that's probability sampling. There are numbers that I can associate with probabilities and different parts at every level of your research. You'll be able to calculate error. You'll be able to calculate, of course, variance, standard deviation, your means. This is a good thing. And these are the types. We have simple, stratified, cluster, and systematic. We'll talk about those a little more in depth in a minute. In simple random sampling, every subject in a population has the same probability of being selected. What happens here is we randomly select people at every turn of the research, okay? The ideal method of sampling, this would require you guys to have access to an entire population. If you're studying the nurses in your hospital only, that's your population as you've defined it as the researcher, then you can get a list of your entire population and ask questions and draw inferences. Okay? To achieve the perfect random sampling, the sample must be finite. Members of the population are accessible, all of them, and listed to avoid bias. In other words, we would like to get a listing of names or subjects and then randomly assign numbers to each of their names. And then as we go to sample, or after we decide what the sample size would be, we would randomly select the numbers. There are random number generators readily available to you online or even in your books, mostly in Excel as a great one. So you would randomly select numbers, and then those are the subjects which you would sample from. Here's a little illustration for simple random samples. Here's my randomly assigned number list, and maybe I would come to a random number generator, and there would be, I could randomly select 2, 12, 7, 20, 50, etc., etc., until I have the appropriate number of people to sample. So, of course, I would sample, here's Kathy, whoever number 12 would be, whoever's number 7, etc., etc. At random, I pick these people And you see in the illustration there, there's 2, 4, and 5. They were selected. Okay. In stratified sampling, we want to divide. This would be where the researcher divides the population into subgroups according to a characteristic or an attribute of interest in your research question. Then you would randomly select a certain number of people to sample from these subgroups. So you're not sampling the whole strata. So you're sampling a certain number, pre-decided number from each strata. For example, the city's housing council is to carry out a survey into the quality of homes in the neighborhoods there in the city. There are 1,500 homes in their part of the city. And they decide to divide these homes in the population into 3 categories based on privately owned homes. By the way, note, they decide to divide up. So this is not some pre-existing, this is something they do. Okay? Privately owned homes, 720, rentals are 592, and rented from private landlords, 188. Okay, so proportionately sized subsamples are then randomly selected from each strata, and that becomes we put them all together and get our sample, okay, our overall sample for our study. This is just a real basic example of stratified. We can definitely get a lot more technical, but this is basically the thing. The researcher decides which strata are to exist, and then you decide, you sample from each subgroup. Okay? As opposed to cluster sampling. Okay, now cluster sampling, this is the technique in which existing groupings or clusters within the population are identified. So the researcher merely goes out to identify the different subgroups that already exist, and then he'll randomly select different clusters and sample the entire population of the cluster. These are pre-existing groups, and depending upon which clusters we're going to sample from, we take all the members of each cluster into our sample. Okie doke. Now, the last one, systematic sampling. I think this is one of the simplest ones to remember. This involves, and to be real general, selecting your subjects according to a standardized rule. And that's a very general definition of it. But what I have in this little bulleted list is the most prominent version of systematic sampling. We can create or obtain a list of the whole population. Then you want to pick a random starting point in the list. And then we'll select every case person. Now, how do we get the number K? The population size, the total in my population, divided by the total number I would like to have in my sample. Okay? You want to definitely make sure that your population list is not developed with any ranking order, or it's not developed in groupings, for example. This would create bias, and that's bad. Remember, bias is the enemy of statistics. Okay? It's a systematic error. If you have a list that had someone collected, maybe you're looking at politicians and their parties, and they maybe listed the first 50 were Democrats, second 100 were the independents, etc., and then the Republicans were in the end. They're all grouped like that. We want them to be at random. Okay, you'd like to have a randomized list of your population. Then you go into your systematic method of selecting every case person at your starting point that you determine. Okay? So you really need to be careful here. Don't forget, you want your list to not be developed with any type of bias or ranking order. Bias is bad. And of course, there is non-probability sampling. This does not have the same opportunity for selection for all members of the population. Okay, so in other words, all members of the population do not have the same probability of being selected in the sample. There could be convenience sampling, which is you're in the right place, right time. The easiest group to be sampled is the one that gets sampled. Saves time and cost. Quota sampling is where our researcher decides, I'm going to have 50 women and 50 men, goes into the lobby, and once they have 50 men and 50 women, they're gone. Okay? We also look at purposive sampling, where we have the subjects or information-rich cases. Maybe we would go to MD Anderson if we're studying cancer, and select only from that hospital as opposed to the other cancer wards in different hospitals in Texas. Network sampling utilizes social networks, which frequently share characteristics. Maybe we're trying to decide, we're taking a look at people who utilize the online auctions, and we go to different auction networks, to see what's going on there. And it's a useful sample of groups, and that might be hard otherwise to obtain. But you have to be careful. That's very thin line there about the bias there. Theoretical sampling used to develop a theory. Theoretical sampling could help you develop a question for a larger research. So things about these can be good if they're non-probability sampling. These are not all bad. They all have their place in real research, okay? But as far as something that you're going to have less error and less bias, then, we would like to have no bias. If you have any bias that enters into your research, throw it out. You may have gone through a lot of hard work to get your numbers, and they're just dead now. They're useless. Be careful about bias. It's a big no-no. As far as standard error, there's always going to be some error. In other words, error is just the difference between your sample's measurements and the population's measurements. We don't live in a perfect world, so you're not going to get perfectly proportionate sample to the population. But you want to get as close as possible. That's all I got for you guys now, and please be in touch if you have any questions for me. Alrighty, have a great week.